All right, and I'm officially recording, so it is January 27th, 2025. Wanted to welcome everyone to the first meeting of data science. I will discuss I'll kind of go through the welcome at first. We'll see who's here, why you're here. I think most of the people, I think I know why you're here, because you have to take it, but see if there's anyone else joining us online here. But format of this class will be a little different. Those of you who took geostats, I think even with geostats, there's going to be a lot less me talking and just us doing. And for the first class today, all we're going to do is we're going to make sure you all can log in, and then we're going to go do a model where we finished up with geostats last semester. So remember, we did all that spatial interpolation and all that other stuff. We're going to finish with that because at some point in time, we're going to be able to automate that process. Now, what's the word automate mean? Make it automatic, exactly. Because who wants to go and draw, who wants to go and click all those other buttons? I don't want to do that. So we can automate these processes, and so that we can do these over and over and eventually convert these to programming code. Now, some of us here, I think a few of us here are familiar with programming. Programming, I think a lot of people think it's a really bad or hard thing. It's not. It's just going to be a set of instructions so we can automate processes. I actually got my 6-year-old this weekend starting on programming. And it's like, it's not really that hard. You know what I mean? He just makes the little scratch jump 3 places. And, he just does like right, and picks the little acorn, and then you look at it, convert it to code, and you're like, oh, cool. There's a little code called move right, move right, move right. You know what I'm talking about, right, Daniel? And then eventually, like, hey, I'm going to do it 5 times. All right. Instead of saying move right, move right, move right, let me just repeat the move right 5 times. And so, we're going to do these. And a lot of this is going to be done within the confines of Python programming, but we're going to introduce everyone to something called, BASIC, which is literally like basic programming. We're going to start that next week. So it's going to be a lot different, a lot less lecture, more hands-on. So just be prepared. Make sure we're able to log into our ArcGIS Pro. And those of you kind of coming from this class, I just saw you. So you all should be able to log in and be ready to go. Should is the operative word. Should. Okay. I place all downloadable files. And this class is a little different in that you'll just see week number 1, I've got everything sitting there. I've got I got the homework, I got the exercises, I got Excel files and all those other things here. Because this class is called data science, and what is data? This has got a fundamental questions the first couple minutes of class, but what is data? It's something different to me than you. Raw information, kinda. What's information? What's that? Validated data. It's basically like factual statement. I am, 5'9", you're 5'7", you're 5'3", Andy is 5'5", David is 6'0", and or whatever. I don't know how tall. You know what I mean. But you know what I mean, right? So that's all information, but it's put in a formal format. So all right, I got a column called name where I put Daniel and David and Andy and Michael, and then I put another column called height, and I got to put a little height right there, and so I can graph one versus the other or do something, something like that. How's it going, Alondra? Good to see you in person. And so to me, data is just information in a formal and accepted and kind of codified way. And there's lots of different ways. To me, I love Excel and ArcGIS Pro, but we have things like JSON, JavaScript object notations, which are able to store data, or ASCII or whatever. But I always like just to go back to Excel and do all these things as well. And so we're going to install some, some software on here, but particularly with programming, there's a lot of trial and error. And so that's part of the problem solving process. I just had a meeting with my graduate students, And I really try to impart about how important problem solving is in the real world. And jokingly, I kind of said that, problem solving is like, hey, we've got a conference and, we're going to the conference and I'm meeting them there and they're like, well, where's the conference at? I'm like, this is something you should figure out. Well, how do I get there? How do I park? I'm like, this is all stuff you should figure out a while ago. And the same thing with, programming. You run a program and it, didn't get what you thought, and you're like, it didn't run, and just I'm done. Okay, and so we're not, really going to take a different approach to that. So to me, it's trial and error, and debugging and all those other things. I'm not going to get too big into the debugging and all that other good stuff because, to be honest with you, there's probably some people in this room here that are better programmers than me, but I'm just going to kind of expose you to some of the ArcGIS Pro, programming, fundamentals, algorithms, all those other things that I'm good at. So we're going to do things like with metadata, accessing databases, and then I'm going to do something called the Jacquard Index, where I compare one column to the other, and all those other things. But there's tons and tons of other ways that we can automate ArcGIS Pro software processes, so we don't have to go, click on this and click on this and click on this. So we can put them into models and programming applications as well. So to me, the development of problem-solving skills is essential as you enter, the workforce. So like, hey, it was supposed to say print world and it didn't say print world. So something's wrong here in these 2 lines of code. And so we work hard to do that because what we talk about here, especially with programming, is syntax. Meaning, how does it actually write out? Do I use the word print? Do I use the word print out? Do I use the word display? What are the different ways that I can use this syntax? I say hola to someone, well, they don't know what that means, but I go to Puerto Rico or Spain, they know exactly what I'm talking about. So it's going to be environment specific. So I posted resources that we can utilize, a lot of different resources, but this is an introductory level class here. So I see the people in this room here, they've all taken GIS before, familiar enough with GIS to really do some pretty amazing things, especially if you took geostats right off the bat. And so I'll go through everyone in class here probably after the break to make sure everyone's here and all that other good stuff to do that. But during the first week of class, we're going to discuss modeling techniques. A lot of times people think of this word modeling really scary. All we're going to do is automate processes. And we already did this here, but we're just going to do it over and over again to do some interpolation. So things like add XY, interpolation. And so if you've taken 34, 35, I know, David, you've taken 40, 10, it's preferred. Make sure you're able to log into and access ArcGIS Pro. And everyone in this room is able to do that because you've taken my classes before. Okay, so you're all able to do it. Hopefully everyone online, I see a couple people here, and I know you all, and I know you're able to access it as well. And so this will be the first assignment, and hopefully everyone was able to log into ArcGIS Pro in the previous 2 weeks that I was gone. And so I think I'm pretty familiar with that. So also I want to place a focus on soft skills. So part of the final exam is going to be, you're going to teach us how to do something associated with class. So this class is pretty simple, where that it's 10 exercises, a final, I think it's, a final and a 10 exercises, a final and a project. And so the project is you teach us how to do something in a video. And so one of the lessons that we do, you show us how to do it. And then we have something called GERS, Graduate and Undergraduate Research Symposium. And so if you present at that, you don't even have to take the final. Okay, so so you don't even have to take the final. Okay, so you don't have to take the final. You know what I'm saying, right? Present at GERS so I don't have to give the final. Someone last semester insisted on taking the final, and they insisted on taking the final. They didn't want they dug their heels in and they didn't want to present at GERS. And so they took the final. But I say that jokingly because I want us to really improve your soft skills. You know, improve your soft skills and really facilitate the relationships outside of this classroom, because it's great that, you let me know that you know how to program in Python, but I'm just a professor here. How well can you show that to future employers or, research advisors or other folks like that? We have 3 people in class. We've got Andy, we've got Michael, we've got Chima, who's joining us online right now. They've all taken this class last spring, and last spring was the first time I ever offered this class. So this is a brand new class. It's created, or I developed it in support of a NASA grant that we received about 1.5 years, 2 years ago. And so they're paid to support you for this. So maybe next week, I was talking about before class, at 3:00, hey, they can come in and just be here so they can help finish up the exercise or whatever. I'd be happy to offer up their resources, offer up their services, and them do that with the modeling and whatnot. So, like I said, this class will be composed of 10 weekly projects and a final exam. Students who are registered as undergraduates do not need to take the final exam. So you only be graded through the project. Are you registered as an undergrad or grad?
I'm still undergrad. I was supposed to, yeah.
But are you registered as an undergrad or?
I think I'm registered as undergrad.
Okay.
Yeah.
And I can look at that later.
Okay.
Students who present at the GERS will not need to take to the final. You'll just get 100 on it. It'll be calculated or whatever. But to me, about the GERS here, click on the little link, follow the directions for it. I've kind of grown in my old age, grown a little old and weary of people like emailing me saying, well, when's GERS? When's the deadline? And I'm like, I don't know. You follow the little page and go to it. I don't have the resources or time or bandwidth to really go and click on a link and copy and paste stuff for you if this is what you really want to do. And then obviously, connect with me through here. This is our classroom link. So if you're not able to make class, obviously, if you're sick, please don't come in. And I'll post a recording of this class. But keep in mind, if you're registered for face-to-face, you're expected to attend online. Me, I have a lot more latitude and leeway with that than other professors. So, if you're doing well and all that other good stuff, then if you're doing well and all that other good stuff, you can attend asynchronously or definitely online. Join us. Me personally, I always like being face to face because I know what I'm going to do. I'm going to go to one of my other screens and just listen for my name to be called, and then just start saying stuff that sounds smart, and then go back to watching my movie or whatever I'm doing there. So, okay, but make sure to reacclimate yourself. So we're going to start talking about ArcGIS Pro. I'll go through the syllabus, who's here, and all that other good stuff, because this is still kind of technically our first class meeting here. But if you've taken my classes before, under modules, I've got everything here ready for the class. I've got the syllabus, my instructor information, resources, how to work with zip files. And then we've got about 11 weeks attached to this class here, because in March, I'm going to go in Detroit for the AEG. And I think there was another week we missed because of a holiday. And so I don't want to squish everything. I really just don't want to squish everything together. And so I've kind of given us 11 weeks worth of work. I've taken some resources that NASA's provided through our partnership with them. And so we might be doing, some online training with NASA, some things that I've developed from scratch, some other resources that we have. But you can see here, I've got week 1, I've got the course materials, exercise 1 that you're going to submit, and then a little video that I've created in support of this. And so we've got week 2, and I just call them units in this case here, but I've got unit 2, 3, 4, all the way to 11. And I think I already have the final exam there if people really want to take it, and the class, the final project. And I might have to change the point value. No, I don't think I have to change the point value in that, and the rubric for those, but we'll discuss those a little bit later. Obviously, I love to show off how all the great papers I've done, so I put those down there. Because a lot of those utilize big data. you know. And here, when we talk about big data here, we're going to be looking at like death databases of a couple 100,000 records, you know. And at the end of this day, you know, that's not really all that big. You know, when we talk about data, you know, you scan in your little thing at Food Line, you know, how many of those things are getting scanned every day? You know, thousands, millions of all those. So, you know, we have AI, ML to go through and really create some pretty neat things, you know, really neat things with those. And, you know, I think I was kind of showing Daniel some of the stuff I was doing before with, you know, satellite drone imagery and extracting information from drones, looking for potential grave sites in some of these historic African American graves. And it's really kind of forward thinking and really neat stuff at looking at some of the patterns in data that already sits there and exists. And so when you look at something like, you know, the buying patterns, you know, what are people buying? You know, everyone's buying milk. So where are you going to put the milk? You're going to put it as far away as possible. So you have to walk all the way back there to, you know, buy it and like, oh, I see this on sale and that on sale. And okay, cool. You know, and so there's intentionality and purposefulness with all these decisions, you know, that are made, you know, and we see these every single day. There's a whole science on, you know, analytics. You know, I have a friend of mine that I grew up with, and that's what he does. He works for Walmart Connect now, but he worked for Facebook and all these other things. And, you know, when you click on, you know, hey, I want to buy this at Amazon, and what do they say down at the bottom? Well, people who bought this also bought this too. Are you sure? You know, and these days I'm making a concerted effort. I think I've bought one thing off of Amazon since Christmas because I saw some special on it, and I was like, I don't want to buy Amazon because, you know, if I need to buy socks or something like that, I can just click a button. If I really want socks bad enough while I'm out, it's going to be important enough for me to remember, go buy the socks while I'm out. You know what I mean? And they cost about the same, you know, at the end of the day, you know, but I can click a button and they can show up the next day. And so I've got some external links. These are some small basic resources, Python. We are going to look at something called R. I really like R. I wish I were better at R, but it's an open source statistical programming language. So we'll spend a week on R. And this semester, I've really tried to shore up a little bit of the R resources that I will provide as well. That I'll provide as well. Let me go through the syllabus real quick, and then we'll kind of I'll give my little spiel. And then after the break, we'll get to work on ArcGIS Pro. And we're going to kind of hit it, you know, hit it pretty hard right there. So this class is Geography 5320 or 43 or 4820, but this is data science. This is when we meet here. I'm trying to kind of highlight some of the big things here. Okay, so our project is going to be worth 100 points. Final exam is going to be worth 50, so you don't have to take that final. So 250 points are going to be offered for this class. You know, for geostats, it was a lot more assignments. You know, we had the Esri assignments, we had a weekly assignment, we had a little readings, we had a lot of kind of different things going on. We have 11 weeks, we got 10 assignments. In the middle of the semester, we're going to just go through R, we're going to take a week off. That's where I'm going to present the final project. And then this project, like I said before, you're going to do a tutorial on something that you learn. Hey, this is how I convert COVID data to GIS data. This is how I write a little programming code. Just a little snippet here. Now, this is going to entail data. So it'll entail some programming, but things about open data. The whole idea of my conference or workshop 2 weeks ago was called FAIR. Findable, accessible, interoperable, and reusable open systems. You know, because these days when, you know, people give me money for this project, what should I be doing with the data that I use? I should be sharing it. What do people do? I don't want to share this, you know. And so there's been this push for fair and open data because unfortunately, you know, even with data literacy and access to data, we've got the haves and the have-nots, you know. And so even the people with best software and SaaS and the best statistical programming, capabilities. They have all access to the best data, while people who don't even have access to the data have limited access to the resources to do anything with that. And so what the goal of that is to kind of decrease that schism. So we have something called Code. Daniel's working on that. Chima does some work on that, where we have a community-wide, it's called Center for Data Equity, where we're creating a campus-wide data hub, so that, hey, I can get NC counties and add them to my GIS data. I can get the COVID data, and hopefully Daniel can be part of getting some of the drone imagery for campus, or thermal drone imagery or infrared drone imagery that we can capture and start to do some really neat things with that. So we've got assignments here. If you're an undergraduate student, meaning you're taking this as an undergraduate student, the geography, I think it's called 4820 or 4830, you're taking it as that. You do not have to do the final exam. That'd be great if you did, but you don't need to, and I encourage people not to take the final exam. But I really encourage the project here. Class attendance. Obviously, if you're joining us online and you're signed up for the online class, I just make sure you log in. Okay, so I go to log in. So if I see that you never log in, and I can also see how long people log in for, and so I always get complaints about, like, I don't know what I'm doing, and I can see they've been logged in for 3 minutes, and it becomes a little problematic there. So we got labs, we got the projects, and as the date gets closer, I'll show you some of the great projects that people have done. I'm amazed at some of the great things people done utilizing technology, and just really what I want with the project is you being an expert at something. We had someone who went and analyzed gun deaths, and so we went through North Carolina vital statistics database. We got a list of every single person who died, and they're coded by what they died of. So, hey, let's just look at the 872 gun deaths, and they went through and did an analysis. All right, I clicked on this, I clicked the little summarize button. We all know what summarize means. And I clicked on it by race, and we can see which race and age of people have the highest rate of gun deaths. And we create a nice, pretty graph for those that maybe people like us don't necessarily care about, but people who aren't data literate will understand. So I really like those. We have some Azure exercises that'll be there, but we have building geoprocessing models. Hopefully, has anyone taken the building geoprocessing models yet? Well, you're gonna get a. You did? Oh,
No, I tried.
oh.
I've done the training, but that's all.
Yes, ACC or the ACC.
I don't know. It's your password. All right. You're supposed to sign in using your like your NCC.
You would think that they're after.
Okay. We'll address that at the break. Andy's pretty good at those. Student expectations, academic dishonesty here. I think I have something about incompletes. Like I said, I've said to students, incompletes given at my discretion. If something comes up, let me know, but I hate to give incompletes just because of Canvas doesn't work nicely with it. So I have to combine 2 grade books together. And so make sure you're up to date with everything. Last year in this class, someone's like, I need an incomplete. I said, I don't even know who you are. You haven't submitted anything yet whatsoever. And so that becomes, well, I swear I logged in. You've been logged in for 4 minutes. And I'm nice, but I'm not I'm nice to, I'm nice to a point, and then that point kind of stopped. And so, if you do need to take an incomplete, make sure it is for a good and decent reason. Good and decent reason, but that's about it. Make sure everything you turn in is your own, because you can work with folks here, but I want you to be able to just write your own code, and not for my sake, but so you can get out there and just say, I did a little Python programming. I've automated some processes here. To me, those are really important ways that you can, increase your skill set. A lot of people, it's hard. Classes, fairly hard for some people. For some people, it's going to be really, really easy. And if it's hard for you, at least, get through, do the hard stuff, and, say you did it, because I think programming is not necessarily intuitive to, everyone. So this is what we've got going on this week here. Like I said, we're going to focus on about 11 weeks right here, just because I'm going to be gone. So we've got 10 exercises. We've got final exam for graduate students if you choose to do it. And then we got GERS, which is coming up, Graduate and Undergraduate Research Symposium, because we're going to be kind of focusing on basic programming here, and then we're going to kind of work with wrangling, voter statistics, big databases, data cleaning. And that's another thing that I do with Python, meaning like you're going to go through the North NCDOT database of all the roads, and you're going to see like negative speed limits. I'm like, there shouldn't be negative speed limits, but who's going to check all 1 million of those records? I'm not. And so we can write Python programming code that goes through and, hey, if it's a negative, probably make it a positive. Or we can do lots of other things to kind of check to do these. We're also going to look at metadata and ISO standards, so we can pull information from metadata. And then we're actually going to do some machine learning and AI. We're going to do an asset exercise, but in class, what we have is I had a student who went and collected drone imagery of the entire parking lot. And so we have AI models to go and detect how many cars are in the parking lot. It's pretty cool. And so they go and pick out all the cars right there. And to me, this is kind of the future of machine learning, artificial intelligence with GIS. So we can go and, hey, let's see what time, this was taken at 9 o'clock, 12 o'clock, 4 o'clock. How many cars are in the parking lot? So the parking manager, who's a graduate of our department, can, figure out where we need parking. But it seems like they're always taking it away here. They just make you park down at the, the lot, park down at the parking deck right there. But some really neat, imagine how long it would take to count all the cars. Long time, error-prone process. And so we can use AI ML to do some of those. So I look forward to that, because these are all things that I'm still learning as well. This stuff wasn't around when I started GIS, it wasn't even around, 6-7 years ago. So this is all kind of relatively new stuff that I really want you all to get in at the ground floor and to be good at, and just kind of pick stuff that's going to be good for you. We got chemistry people here, we've got, drone people here, we got natural hazards people here, we got online GIS people here. What are you doing now, Alondra? Are you doing utilities stuff? We got someone who works in utilities. Are you working from home? How is it? You like it? You like the paycheck? Okay. That's got to work for now. So you doing ArcGIS Pro or something different? Small what? Okay, cool. Are you living at home or what's that? Oh, okay. Okay, cool. No, good deal. No, good deal. I'll talk to you more about some of the stuff you're doing, because it sounds pretty cool. Are you doing it for the city? Oh, okay, cool. Awesome. Yeah, that's really, really cool. Okay. So we've got that. Any questions for me? I'll kind of talk a little bit. I'll give a little bit of a break here, and then we are going to get started on the first exercise after the break. And by the time that break ends, I want everyone to be able to log into ArcGIS Pro too as well. And so today we're going to talk about introduction to data science. Like I said before, that doesn't look right. Okay, there we go. All right, so like I said before, to me, data is just information that has been kind of stored in a codified or well agreed upon convention. So what, the big thing now is that there's massive amounts of data for any aspect of our life, online, offline, real time. I walk around right now with this little thing on my watch. It tells me how many steps I've taken, what my heart rate is, everything. And this is what we call biometrics, but it's got a geospatial component to it. And the focus of this class is largely going to be on the geospatial. But as you can imagine, this is how folks like Instagram and TikTok and Facebook, they make their living. What do they care about? Views. How many people looks at it? And then you get big ads, which get all the big money and all those other things. But at the end of the day, we call those things analytics. And that's just a fancy way of saying statistics about these things. We have datafication, so it's taking all aspects of life and turning them into data. So all the steps that I take back and forth, my running pace, I go running, and it keeps track of the elevation that I had, my heart rate, how fast I'm running up that hill. And these are things that didn't exist 20 years ago. And I just wear this thing on my watch. I plug it in when I drive to work every 5 or 6 days. And it just, if I wear it to bed, it tells me what my heart rate is while I sleep and how stressed I am. And it's amazing. And so once we datafy things, we can transform their purpose and turn the information to new forms of value. And so we see companies out there and people for the most part as well, exploit that value for monetary gain. This is what, Facebook does. Why is it free? It's pretty cool, huh? Well, why is the guy who owns Facebook, own an island in Hawaii? He's pretty rich. Well, what's he collected from you all? Your information. That's all, and most of us are willing to just give it away for free. Okay, sure, yeah, I'll give you my information for free, so I can, gossip and, see how Joe, Susie is doing or whatever, you know what I mean, my wife can follow, follow so-and-so on the internet or whatever. And so we have an overabundance of inexpensive computer power and communication capacity. I always kind of joke, is it necessarily a good thing or a bad thing? My brother, he could track down his girlfriend from high school. I was like, do you really want to? Is that really a good thing? Yes or no? And then we have the proliferation of small footprint, low power sensors like Internet of Things that can be connected to web services. So we have what are they called? The purple monitors, purple sensors for the air monitors that are connected to the cloud. And then we have feedback loops between our positive or negative feedback loops between our behavior, environment, and data products with our assessment, evaluation, and analytics. And in this case, assessment and evaluation are two separate things. So data science, and these are just some things that people talked about, is practice, blend of Red Bull fueled hacking and espresso inspired statistics. And so how do we apply those? And here we're going to really just focus on, a couple 100,000, 1 million, 2 million records, but we can get really big really quickly. We can merge all of these things together. And it's not necessarily hacking. And so to make data science it's a lot of things to a lot of people. So this particular class is going to be data science according to me. And so we're going to have some programming. We're going to have some vital statistics databases. We're going to revisit some of our statistics. So David, you haven't taken geostats yet. Oh, you're going to take a little geostats here for a week where you're going to talk about my good old two-tailed t-tests and all that other good stuff here. So we can make hypotheses and prove and disprove these hypotheses, because we carry around these things in our pockets and we see statistics and all these other things and facts. And then last semester we talked about how can we reinforce these with statistics with statistical significances here. And so we have all these statements here. We have data science, data science studies. To me, data is kind of, the one thing about data, it transcends every discipline. People over in history, they work with data, but what type of data do a lot of times people work with in the history department? Not quantitative data, but qualitative data, like oral histories and whatever, but they've got these databases and they store them, they store information about people. The cemetery database that we have is a big Excel spreadsheet, and they have the name of the person and when they lived and what they died of and link to their obituary and all these other things stored right there, so that hopefully at some point in time we can have a little GIS that we click on that links to where they're buried on our particular cemetery. And so it's really interesting. We like looking at data because we can make decisions with these things. At the end of the day, just like with geostatistics, we want to facilitate data-driven decision making. I can't stress that enough. We have someone who works in fires, works with fires. These days, what are they going to do? One of the things I watch forensic files. I love that. And they use the old GIS, like, hey, here are all these fires with all the push pins, so they're all around a certain location. They must be there somewhere or whatever. And I think that, it's interesting because now we can GISify it really, really quickly, incredibly quickly. And so some of the actors here, where we have a data sales, a data business person, a data researcher, these are all just kind of the different actors that we have here to utilize data. Now, what are we going to be? Me, I'm probably some sort of data creative where I'm a jack of all trades. I could probably make some pretty visuals, but data, pretty visuals, but I know how to open up some Excel and do some Python programming code to do these, where you have some front end people who really, they use the visualization products that people, talented analysts are able to make and utilize those. Types of data scientists out there, spatial data science, mathematics, actuary, quality control, data manager, statistician, machine learning. There's all these different types of things that we can do here, but we're going to focus specifically on spatial data science, so that we have X's and Y's attached to information. So we're still going to be doing a lot of our work in ArcGIS Pro for the most part here. So we need to define what data science is by what data scientists get paid to do. What is a data scientist? And this is really a large, a large general term, because you can do a lot of different things with data science here. So like I said before, and to reinforce this, if you take another data science class, or you take one with, Dr. Uma up in chemistry, the stuff you're doing there is probably going to be a little different than what we're doing. But, we're going to do a little programming. We're going to do a little Python within the confines of ArcGIS Pro, because what we try to do is extract meaning and interpret data, tools, methods, machine learning, as well as being human. And so we will do some machine learning. I'm doing some really neat stuff with machine learning. That's like the last week of class here. And we're going to look at some of the NASA stuff. Collecting, cleaning, kind of wrangling data, utilizing statistics and software engineering skills. Because a lot of times, cleaning data, is the data any good? And then exploratory data analysis, we call this EDA or ESDA, exploratory spatial data analysis. So we can find pattern, models, algorithms, and what we're going to build today is just a nice little model. We're just going to do the same thing over and over and over again, so that people can go and I got a research topic here for a thesis sitting here ready to go, and so that we can also communicate these in clear language with nice little pie charts and maps and all those other things instead of big tables and Python code that no one else is going to want to care about or no one cares about. The other thing that we have is the creation, mining, representation, modeling, and cataloging of spatial data. So in this particular case, we're going to talk about something called metadata. Has anyone heard of metadata? Oh, goody. You've heard it from me?
Yes.
Yes, me. Okay, good. I have a nice grant ready to go on metadata from my project a couple weeks ago, and hopefully someone will give me $600,000 to, do stuff on it. And metadata is important because that's data about data. So if I collect a drone image, what are people going to want to know about it? Well, when did you collect it? What day is it? What's the picture of it? And so we have formal data standards to store information about the information, like metadata. And so I think to me, that's a real underappreciated facet of GIS and the geospatial sphere is metadata, because a lot of times when I worked with the military, there were 3 words people at the Pentagon didn't want to hear. What were they?
Probably can't and no, I won't, or something like that.
I don't know. So when was this stuff, flown? When was this stuff created? I don't know. That's not a good answer because you know what they soon said? Well, you better go and create some new data and no. And so, so when we had, we worked with, 100 military installations throughout the world, and we had, firing lines or boundaries or roads on the military installation. They wanted to know when these were all, when all these were created. And I don't know is not an acceptable, it's not an acceptable, answer. And so, we're going to focus the whole week on the cataloging of these data. And hopefully in the future, people give us money because there are metadata standards to increase discoverability. Meaning if you go to our code hub and you go through the trouble of creating a whole new county's data layer and what already exists here, what have you just done? Wasted your time. I want to find a drone image of campus from 2022 and one's already sitting there, just wasted your entire time. And so we want to increase the findability of these data. So that whole idea of fair data, fair, findable, accessible, interoperable, and reusable. What's the word interoperable mean? Yeah, you can use it on multiple platforms. So is this software Alondra working on this? Can she work on the same stuff that I can? Probably not. Maybe it's not very interoperable. Do you guys use shapefiles with your software? No. What do you all use? Feature classes or something special? Something special. So there's something special doesn't work with our something special. So guess what? It's not really interoperable. So what do we plan to do in this class? First week, we're going to do modeling, diagramming the methods that can be performed on spatial data and automated. So we're going to pick up right with interpolation, like week number 11 or 12 of GeoStats last November. We're going to work on programming, creation of code that can be performed over and over on spatial data and automated. So I could just run the code and it runs and I kind of look smart because today you're all going to create Python code. You don't know it. You all create Python code. David's like, oh my gosh. By the time you leave today, you will have created Python code. We're going to do something called data wrangling. And I think this is where I'm good at, is the creation of spatial data from large disparate data sources or stored in cloud bases. Because a lot of times when anyone wants to do a project, whether it's carbon sequestration or SIDS depths or ultra colliders or AD, people come to me with these great ideas about mapping something or doing some spatial analysis. What is my first question always? Where are you going to get the data? That sounds great where we're going to get the location of every person who had COVID this year, but where do you get the data from? Are you going to go and ask every person? I'm not going to do that. Okay. And so where do we get the data? And then some subsidiary questions at what scale? Because we have COVID maps at zip code scale. Is zip code good enough for your research? It better be, unless you want to go and get better data. It better be. Okay, we had some of the fire data that we were looking at the end of the semester. We had the addresses of those, right? And we wanted to associate those with socioeconomics. We have socioeconomic data at the block group level or zip code level. So we've got really fine or coarse data depending on what we have. But my big question is always, where are we going to get the data to do that? Because if not, if we don't have the data out there, you're going to have to go make it yourself. Do you want to make it yourself? In some cases, go make it yourself, and you can call that a dissertation or call that a master's thesis. We have people go out and GPS all the fire hydrants in Oxford, North Carolina, and see where they are. We call it a thesis or do whatever we want to do. And that's what our field mapping class is for, where we don't have data sitting there. Michael, sitting right here in the corner, he went and digitized or collected a GPS unit of all of the emergency call centers on campus. And so now we have a map. Remember that in Geostats where we did the nearest neighbor analysis of all that? That's what he did. So, and what did we learn? I think they were randomly distributed, right? That's kind of what you want, right? You don't want them all clustered, You don't want them all clustered, because the chance of you finding one are probably going to be less if they're clustered. And then data cleaning, ensure it has both spatial and attribute accurate integrity. We have metadata, and then we have artificial intelligence, which I'm like slowly, kind of getting into a little bit. Other things, I want to foster soft skills. And I think it's probably been more of a passion project for me the last few years, just as I see my kids who are probably a little bit younger than you, maybe not David, but not me, but a little bit younger than you, getting out into the workforce, and I think sometimes lacking some of the interpersonal skills and job prep skills, and really maybe misdirection of priorities there, where that. At the end of the day, people hiring folks, they're not going to care. You got straight A's. They don't want you to have a 1.5, but you got a 3.2 or something like that. That's just as good. So really a focus on the process as opposed to the end result, because at the end of the day, the end result is being like Alondra and having that job. That's important. And maybe she doesn't like the job right now, but guess what? She's in a better position than someone who doesn't have a job, because she can use that job to go and apply for another one, which is better. And that's maybe what you're looking to do. Right. And so that's what we're trying to do, get you in that position. Because my first job out of school, I was, I like it, and just work your way up. Presentation skills, writing skills, interpersonal skills, facilitating interpersonal relationships. And so we're going to go to GERS. We're going to go to some of these other things here. I'm taking some students to the North Carolina GIS conference. I like going to something called North Carolina ARC Users Group meeting. And that's, I think it's in Asheville this year, but I've taken a couple students there we go out there, and you're going to meet people who run the GIS for the, Forsyth County or Durham County. We see former students there, especially the North Carolina GIS conference. That's a great one. A lot of our former students go there. Resume writing, cover letter, job searches, internships. What type of professional, are you going to be? I unfortunately had a student, former student email me from about 10 years ago saying, I can't get a job, let me look at your resume. I'm kind of like, and it's a really difficult conversation saying, listen, you really got to represent yourself better. You know what I mean? And it's, you got to represent yourself, better here. Show some of the projects that you have. I know you got a 4.0, and I know you got a 1580 SAT or whatever it is, but that's not all of it. And you got to be able to be personable. Because if you get an interview, that means you can do the job. To get through the interview, you got to show that people want to do the job with you. You know, you show up to this person, for 40 hours, you're spending more time with these people than you are with your family. And so someone's like, I'm not sure I want to spend 40 hours a week with this, this person here who's, telling me how great they are or whatever, or comes off as abrasive, or who's going to be whatever, a Karen or whatever, whatever the new thing is. My wife looks like a Karen, so everyone kind of makes fun of, they kind of make fun of her, So whenever she gets a new haircut, they always say, you're gonna see the manager soon or whatever, so. And so, but, it's, how do you represent yourself in the workforce? So I really want to kind of put in snippets of things like that, because at the end of the day, that's the most important, most important thing. Jobs, internships are important too, get an internship that leads to something bigger and better. So it's 6 o'clock here. We'll get back here at about 6:10, 6:12. And I want to make sure everyone's able to log in, because we're going to start with exercise 1. We're going to start with exercise 1. I'll take a quick break here and we'll kind of refresh myself. And then we got Michael in the front here. We got Andy here. If you need help logging in, I'll be here too. So we'll take a quick break here and then we'll get on to everything. And I'll show everyone how to. Oh. How are we here? Home. See what they can probably. Do you want to do that? Like chat. Do you work online? We like this small world. You doing that stuff for me again? Okay, make sure that it's.
Thank you. The model. So, here's your cameras. So, I didn't know. And then, oh, that's pretty much. Okay. So, I'm going there for some. Yeah. That's how the girl is growing. So you got a piece of thing here? Show up. I'm excited for you then. Cool. Clear. Oh, well. Having a great week here. Having a great week. So much sugar. Yes. To where? Oh. Jerry. Yeah, all day. So are you going? You're going with it?
I celebrate Thanksgiving. I did. I had to be a very, so I did that instead of. I spent time with them. Is everybody working? So I came back. And then, yeah. Just came back.
I'm just looking at some.
Here's some of the view that you can get from the controller while flying. All right, so now that I've got the drone in the air, I'm gonna fly up to about 120 meters. So I can gimbal down and then switch over to the multispectral view. Shows me where there's stress vegetation or where there's healthy vegetation. Healthy vegetation would be identified in red, and stress vegetation orange and down to yellow. So this is a really good way for me to fly over a paddock and get a good sense of what's going on in the paddock, where some of the plants might be stressed. That way I can go back and manage those issues. And I can do all of this without processing any data on my computer. Do the side-by-side view so that I can see my multispectral image and my RGB image at the same time. So in this paddock, I can see that a lot of the trees are bright green, have a lot of chlorophyll in them, look very healthy. Some of the grass in the paddock looks pretty good. There are other areas in the paddock that might need more water, more nutrients. So I can use this information to manage an operation or a paddock. When I'm ready to bring the drone home, I can then just hit return to home and it'll automatically come back to it. That's the live view of the DJI match. What is it?
Oh, I don't.
Okay. Daniel. See this right here? All right. If I forget, I'm gonna just blame you, okay? All right. All right. Some of the things we're doing. We just bought a drone. This is for maybe anyone who wants to know. All right. We just bought a drone, and most of the time, drones are going to look at what we call true color imagery, meaning this is what your eyes see. Why is this thing blue? Why is her shirt blue? Why? Because it's what's being reflected. I think most of us know the EM spectrum. There's a lot more that your eyes can see. And so one of the things we just bought, came in today, Daniel's kind of working on is we were playing with this, is that we have a multispectral camera. And I think this is it? I think this is it, but yeah, this is it. Looks a lot like it. That looks at plant health, and it uses something called NDVI, Normalized Differential Vegetation Index, which basically just looks like the ratio of proportion between the lengths of one of the infrared waves, which is a little bit longer than red, versus red. And so it ranges from -1 to +1. But waiting for David to nod his head and say, yes, that's right.
I kind of remember that.
Okay, good. All right. So waiting for him to nod his head. So we've got this imagery that kind of does this stuff, where basically the red has the healthiest vegetation. Is to me, it just all looks green. Okay, it looks green. Cool. Green. It could be healthy green, not healthy green. It doesn't matter. And we're doing this for the purposes of looking at like cemeteries, because we see these cemeteries, we see these kind of plots right here. but a lot of these places don't have headstones. And so we're hoping to see if not only this true color imagery, but this false color imagery was going to elucidate some patterns that, hey, these could be some potential grave sites that have that are unmarked. And so when people go to create new resting places for people, or cemetery plots for people, they're not digging up the remains of people who are already there, who are already there. And so, and then we're going to go and confirm it with something called ground penetrating radar, which looks like a little a little tractor or lawnmower that sends high frequency pulses into the ground, and then it returns them to see if there's like people there, basically. And so you got lower frequency that go down to like the bedrock. They typically use it for utilities. Obviously, you walk around utility, you're not gonna, dig stuff up because, most of my wife works in utilities for a living, telecommunications for a living, and probably every couple of weeks they get a call that someone dug something up, and, because the maps were outdated and all those other things there. And some of these utilities are really small. All right, you're going to be out of your internet for a bit, but imagine like going through and digging up a gas line or a water line or something like that. Just to imagine some of the logistical, not only financial challenges that presents. So, but we're creating this imagery that looks like this, that we can superimpose on top of each other, which I think is just really, really interesting. But I'm pretty sure this stuff right here, Daniel, we looked at this, right?
I'm not sure.
It's a pre-flight check. I'm just asking Daniel because I want to be able to save the photo here as a RGB plus multispectral. Yeah, DJI Pilot 2. Yep. This is what we're looking at here. Okay. I'm not going to do that because there's got to be another way to do it. So I'm going to figure out how to do it the right way. Because you could probably do that, but I want photo. I want an actual photo here. So I'm kind of a little anxious to play with that. But we got class here. And so today, what we're going to do is we're going to go to week number 1, and we're just going to start working on exercise number 1. We're going to do kind of a little tutorial and a little refresher on the GIS and how to do this. First of all, these are all stored as zip files. You all know how I love zip files because I can put all different types of files in there. And so I'm just going to click on week number 1 course materials. And I'm going to download this here. Okay. And I'm going to just click on my little downloads button right here. Now, after I have the zip file, what is an important thing I need to do? Extract. Yep, extract. Because if I click on it, you can see all the other files within here. Okay, so I'm going to click on extract. Where do you extract it to? Wherever you want to, wherever you're going to remember. Okay, and this is part of file management and saving people's time, most importantly, your own time. Because I just go back to my downloads and look for everything. But if I was really meaningful and purposeful about it, I would store it in my, spring 2025 data science class. And so I'm just going to save it here in my downloads here. It's a relatively small file here, but it does have some big things in it. And then when I click on week 1, I've got everything sitting here. So I've got the presentation that I gave here. I've got exercise 1. I've got in-class exercise week 1. Do I want to do an in-class exercise? Okay, I got in-class exercise week 1. I got exercise 1. I got notes and all those other things here. I've got exercise 1 here. And so what I'm going to look at for exercise 1 is the homework that we're going to turn in. Because we're gonna start on, we can start on the exercise here. Okay. All right, let's go through this model here, okay? Let's open everything up too. Well, I don't wanna throw too much at you here. I got a folder here called climate data. Oh, look at all this stuff here, wow. Okay. But what I want us to be able to do is I want to click on exercise 1 and then click on exercise 1 APRX. So double click on that and in theory, everything should open up ready to go. Your ArcGIS Pro up, ready to go. You're signed in using your NCCU username and password. It's up here ready to go. I've added everyone here. You only need to log in once. It'd be funny if it asked me to log. Yep, there's TJ right up there. That's me. Oh, cool. So what all opened up for you here? Colleges and universities. Okay, so we got table of contents right there. Do we have any standalone tables here? What's it called? Air Max 2023-1107. What do you think that table represents? The maximum air temperature. In this case, I'm pulling from the Climate Prediction Center. But let's look at the quote unquote data that we have here. So if we were to right mouse click, open, what do we have here? Right, when we start thinking about it, we got more than 2,000 records sitting here. I've got a file, I got a column or field called lat. What do you think lat stands for? Latitude. What do you think long stands for? What do you think AMT stands for? Amount. And so at this latitude and longitude, the maximum temperature was at 50 degrees. What do you think ID stands for there? What do you think state stands for? ST. What do you think ST stands for? Okay. All right, question. What does AB stand for though? Look at the latitude and longitude. Maybe that'll help you. Well, look at the latitude. What latitude is 50 degrees? That's way up there, isn't it? Not even in the US. So what quote unquote state or maybe province could it be? Alberta, exactly. Isn't it like the northern edge of the United States, like 4840? Wasn't there something in history class called like 4840 or fight or something like that? You guys missed that lesson? You sick that day. Okay. So this is in Alberta, Canada, because this is part of the Climate Prediction Center. It's got a city here, elevation, time, forget about some of the stuff. Okay, but we want to map latitude, longitude, and amount right here. Okay, so latitude, longitude, and amount right here. And then as you can imagine, if you kind of took a sneak peek to everything else, if we were to click on climate data, I bet Mulrooney probably wants you to do all of these 15 files. Wow.
We automate that.
Okay. We're gonna now I think I'm only gonna have you fill it out for a week or something like that, but we're gonna go through and automate this right now. Now, the other thing that I want to do here is, as you can imagine, where do you think I want to figure out where the temperatures are? Alberta, Canada, or North Carolina? And we did this last semester with what? Air quality, PM. What's the PM in 10 different cities? And what we do? We created an interpolation routine. What was that interpolation routine? Prying, that's one of them, exactly. Splining is another one. I like IDW, inverse distance weighting, right? What does IDW mean? Inverse distance weighting. What does inverse mean? Stick it in the bottom of the denominator. So as you go further away, it has less of an effect by a factor of the distance it is away. Okay. And so if I have that chair, if I want to find the temperature of that chair, Michael's temperature is going to affect that more than mine, probably by a factor of 2, because he's twice as close than I am. And so all it does is run a weighted average based on what? Geography. We all know what weighted averages are, right? I can see Londra back there. Right there. Remember weighted averages? Good. Basically, weighted averages are how we calculate our GPA. Right? That's all you just create weighted averages. You know, that 1 credit C doesn't count as much as the 4 credit A. It better not. Okay, if you just average them all up, you know, I used to do some funny math with my parents back in the day. You know, like, gym, I got that A in gym, it didn't, counterbalance the C in math. I never got C's in math. Okay. But, so we have this right here, okay? So I just want to kind of introduce us to this right here. So first thing we want to do is take the Esri tutorial titled Building Geoprocessing Models Using ArcGIS Pro. Okay, build it up. Okay. So just go through and take it. I've taken it before. I've probably taken 20 or 30 of these different, classes. All right. In the exercise, you'll see 2 files. Colleges and universities represent colleges as points in the state of North Carolina, while Air Max GIS 2023-1107, that's the convention utilized by, represents the maximum air temperature for a number of stations throughout the whole U.S. My goal is to get the maximum temperature at each of the colleges and universities for 11/7 using the model, which can be replicated for other days of the year, so we don't have to redo this process every single time. Because remember, what are we going to put here? What are we going to put there? And so Barry had some really good ideas about the craging and the splining, and then we did something else, which was called point raster or something like that. Okay, I got to remember it too, to be honest with you, because that's one I don't utilize that much. Okay, so what's our whole goal? And let's kind of think about this goal, because a lot of times I have all these steps right here. I got all these buttons right here. And I think a lot of times people get really overwhelmed by these things. But if you look at the individual steps, you're like, I know how to do this stuff. Okay, first thing we have, can we export the standalone table to a table that is stored within the Exercise 1 database? Yeah, and we're all going to do it together. We'll probably all do it together by hand once, because we still got a couple more hours here. Aren't we like doubling up class this week or no? No. At least Will has the passion to say no. But, so, can we export it? Yeah, and we're going to do these by hand first, and then next we're going to put it into a model and do the same exact thing again, and then you'll order this up auto generate your Python code, and I'll leave the rest for homework. 2, do we display XY data from the newly created table as a feature class in the map showing all temperatures? Yeah, of course. Can you extract out only those stations within 50 miles of the border? Okay, you will have to add the NC counties claim from ArcGIS Online within our organization, or just use the NC Counties feature class that we use for the in-class exercise. All right, let's forget about the in-class exercise, because I don't want to go do it. Okay, we could do that, right? We could only extract out those counties, right? Okay, extract out only those stations. Why? Select by location. Next, run IDW. We do that. We spend all the geostats doing this. And then next, what do? Use this interpolated surface, extract out the values, using the extract point the values, then do the exact same old thing. So let's start working on this here, and we're going to do this all together here. okay? And hopefully those of you online here are joining us all together as well, or you can join us later as we go through and do this. Now, first of all, what are we gonna do first? One, let's export this to a database. Why do I want to export it to the database? What's that? One, I can manipulate it. Two, it's within the database because right now it's stored as a TXT file. It might be a little bit fickle. So what do? I can right mouse click, data, export table. What's the name of the database we're storing it as? Let me go to this little drop down. If I go or I click on this little folder, let me just make sure it's being stored in the right folder. All right, exercise 1. Uh-oh, we already got it sitting here from last year, but that's okay. Oh, maybe not. 27, okay. All right, input table, you can see what it is. The output table, where is it being stored? Geography, EASC 5320, week 1. Well, I'm going to store it. Exercise 1, and I'm just going to store it right here. Air Max 2023 1107, right? So stored right there. Now, all you need to do, there's no reason to type. All you do is just click on little, and for the output table, just change the name of it so it's something you understand, right? Change the name of it so it's something you understand. You all set there, Ken?
Yeah.
Okay. What's up, David? Well, I don't know why you're typing stuff. I don't know why. Okay, now. So what I did was, I didn't get rid of any of the stuff from last year, so
Oh, okay.
it's still sitting there. I should have probably gotten rid of the stuff from last year. Okay. And I'm gonna click OK. Step 1. All right, what do I got there? There's my table. It's called Air Max GIS 2023 1107. All right, cool. There it is. It's got 8,938 records. Imagine running an interpolation routine on that when we're just looking for values within the state of North Carolina. Not going to be fun. Okay. All right, what's the next thing we're going to do? Display XY data. Do we not have display XY data? You did a couple months ago. Okay, let's revisit it. Okay, we're creating data from a table. There's a lot of different ways we can create data from a table. Geocoding, display XY, spatial joins, all that other good stuff. We're going to right mouse click. And in the new versions of ArcGIS Pro, it is create points from table, XY table to point. Now, what do we have here? Input table. We have our output feature class. It's going to call it Air Max 2023 1107 XY table to point. Okay, because one of the things I kind of want to do is maintain the consistency. Is you can imagine when I do it over and over and over again, this consistency is going to be pretty easy. Next, the X is the long, the Y is the lat. Does that make sense? Is X longitude, Y latitude? Daniel's nodding his head. He's pretty confident about that. Oh, he's right. Okay, because remember, longitude goes left and right or east and west. Even though we say lat long, really saying YX.
Yeah.
All right, what is this GCSWG, what is it?
Ordinances.
What is that the right one?
Didn't look at the initial, I didn't look at the original.
No, this is right, okay? Now, yes, why? Because we're just saying, hey, that X and Y, they are latitude and longitude. GCS stands for Geographic Coordinate System using the World Geodetic Survey from 1984. Okay, why? Because the way that we measure the Earth is different from 1984, 1927, 1866, when we started having worldwide measurements. Why? Because the length of a degree has slightly changed because the Earth, our way of measuring it has gotten better and better. Okay, so we'll go with the 1984. Okay, all right, I'm going to click OK. Now, what do you think the result of this should be? Bunch of points. Where? All over, even Alberta, even in App. Boom, look what we got there. Well, I even got one in Bermuda too. All right, who's got something that looks like this? All right, good, good. Mary, Philip, you all good there? You not good? Okay. Now look what we got here. Why is the US kind of tilted? Why is the US tilted? Why? It's kind of selfish, but I displayed this map as North Carolina State Plains, so we were focused on North Carolina.
Projection.
So we don't care about the rest of the US. Okay, that's basically all that happens. Just for the heck of it, I'll show you a little thing we can do here. I can right mouse click a little symbology, and I can do a graduated symbol on amount. And look what we got here. Does this make sense? Does this make sense? Bigger dots down here, smaller dots up there. Does that make sense?
Oh, yes, because it's max air temp.
Maybe the max air temp, exactly. And then we can look for some smaller, like regional variations here, right? But we're just going to export out North Carolina to begin with in a little bit. And so we can see some of these here as well. Okay, so we're going to go to symbology. I'm just going to go back to my single symbol. I'm going to go back to my single symbol. There we go. And I'm going to make these red. There we go. Okay. All right, are we done with step 2 or step 3? Okay. Extract only out those counties, stations within 50 miles of a border of North Carolina. You will have to add the NC County State Plain feature class within our organization, or just use NC County's feature class that we used previously. All right. How do we look for the NC counties? How do we add data? Exactly, add data. Browse. All right, how do we add it? Now, if I happen to click on databases and go to exercise 1, you might see an NC County sitting there already. right? If you wanted to. Just because I didn't get rid of all the stuff from last year. Okay? Or I could go to where? I could go to my organization, type on the word counties. I gotta learn to spell it correctly. Or type in NC counties. Wow, there's a lot of NC. Ooh. Okay, there it is, NC County State Plane. And I can add it there too as well. Remember last semester, someone went and like deleted one of the counties? I'm still mad about that. Yep. It's still missing. Still missing. That's not gonna matter though with this because we're doing within 50 miles, anything within that county be within 50. Okay. Okay. Now, what do we want to do? We
Dr.
just want to
Mulrooney?
pick out everything within 50 miles. Why did I say 50 miles? Why don't we just pick everything out within North Carolina? What'd you say, Will? Yeah, that's gonna impact the temperature of places in North Carolina. So North Carolina isn't an island, especially when it comes to like climatic and environmental factors, like air quality, water quality, temperature. Temperature just doesn't stop right at the border. These are administrative boundaries that we place there. All right, great. You have a question? I see your hand up. He just wants to wait.
Yes,
time.
sir.
Yeah.
Yes, sir. Okay. 24 just on. Okay, never mind. Okay, so what my question was going to be was I'm not able to access that network from here at home, right? That's correct, right? Even though I'm signed in.
Yeah, you can.
Okay, well, I was able to, in the meantime, with my hand up, I was able to find the regular NC counties
Yeah.
from where I had used before, but I wasn't able to find the state plane. So that was my question, but
Okay. All
I
right.
was able to
thanks.
find it.
Yeah, if you're signed in for someone from Central, you should be able to access it through your organization. And I was kind of joking because last semester someone deleted a county. And so I get mad about that, but in this case, it won't matter because we were kind of looking from the border. All right, next. Extract out only those stations within 50 miles of the border of North Carolina. How do we do this? Select by location. So select by location. What do I want to find? I want to find Air Max within a distance of NC counties project 50 miles. And I'll leave this up here for a second while I go and find that I give myself notes to do every semester and NC counties, whatever your NC counties is. Okay. All right, so we got this. What do you think this should look like?
Look like a buffer.
Yeah, exactly. So I'm gonna click apply. What do you think? Boom. We got everything within 50 miles of the border around it. And so now what do we do with this? Let's export these. So right mouse click, data, export features. Make sure you give it a name that you understand. I'm not gonna, sit here and lecture. I'm gonna call this Air Max 2023 1107. I'll call it study area. So now I can get rid of this. Remove. How's this look? All right, what's next?
I got stuck on.
Mm-hmm.
So I'm on.
Export. Data.
Oh, thank you. That's what I was looking for export, okay. And then here I just.
Give a name that you're gonna understand. Now, you see what I keep doing? Whenever I see something that I don't need anymore in the table of contents, I get rid of it.
Yeah.
I get rid of it. So all I've got is the colleges and universities. They play, that project, I'll probably get rid of, and the Air Max study area. All right, what next after this? Now we're just doing geostats. Do what?
You run your statistics, summarize, or run your statistics you want to run on it, whatever, get your highs, your lows, or whatever you want to do.
Oh. Savior? Then I just right mouse click the I click to go.
Actually, I think point is got rid of it. Okay.
Yeah, I don't need it anymore, so forget it.
Oh, this is anonymous. Oh, thank you.
Okay. All right, so what's next? Run the IDW. We did this in GeoStats. Okay. So IDW, basically what we're gonna do is we're gonna create a raster surface. You know what a raster surface is, right?
Yes.
So we're gonna create a raster surface for the entire state based on the temperature at each of these points. That's all we're gonna do. And if we're gonna want to be a little cute about it here, I'll click the little label button here. I'll right mouse click on properties while I'm thinking of stuff. Oh, label properties here real quick. Come on. Let's try to. Now you see here the temperatures here. So I see 65, 67, 53, all these here. So all I'm going to do is create a surface here for the entire state, and then I'm just going to pick out where the temperatures are in the red. Okay.
Can you show us how to put the labels back in real quick?
Do you need to?
Oh, I guess we don't need to. I
No,
thought
you don't.
want us to do
No,
that.
you don't need to. I was just kind of showing you, like, hey, what's the temperature going to be right here? It's probably going to be somewhere around 76, 77.
Yeah.
Okay, so next.
That's amount, I'm sorry, that's amount for, or.
Yeah, amount.
yeah,
Yep.
Okay, yeah.
Okay, next. All right, because remember what we're doing, because next time we do this, we're gonna go and automate this process so that you just click a little button, it runs, and we're gonna drop and drag these things everywhere. All right, next, we're gonna go tools. And what do we gotta do? IDW Geostatistical Analyst. Yep. So inverse distance weight. So I'm going to double click on this. Yep, geostatistical analyst. What are the input parameters? This is pretty easy, right? The only thing we got left, the air max study area. What's the Z value? Amount. Let's leave everything else the same. All right. Output raster. We'll call it IDW 2023 1107.
Okay. Okay.
We can if we want. Let's just leave it for now because it's not going to matter because we've got everything within the state. Oh, no, we want, sorry about that. IDW, we want spatial analyst,
Oh, we want space.
not geostatistical. That's something slightly different. Spatial analyst.
Thank you.
Who do I blame? Who do I blame? Spatial analyst. I was like, these input parameters look a little different.
Okay.
All right, so input features. Air max, value, amount. IDW, I'll give it something meaningful. What do you want your power to be for your IDW? Let's just leave it the way it is. 2, what does that mean? What does second order mean? Something twice as close will have 4 times more of an effect or weight than something than I am. When I run this, what's this going to look like? Raster. Look at this. Awesome. Who got something that looks like this? I see Alondra did.
Really quickly, can you show how to pull the labels up, numbers on the labels up again?
Yeah.
Up
All right,
the
just right
property.
mouse click. Click on label and then label properties. So you got label. I just turned off the labels, but I can click on label, label properties, and then I can just click on the field that I want. So if I want to, I can click lat. There's a latitude.
For some reason, when I do a mount, mine's giving an
You gotta
invalid.
double, you gotta double click on amount. Make sure the expression is arcade up at the top. Might be a little fickle for you there. Did it work for you?
Something like
Okay, yeah. Rasters get really fickle with this. Let me try it.
okay.
Which one do you want?
That worked. Thanks.
I don't know what I did.
Okay, you did something with it was something with the naming.
Yeah. I saved it in a different database, something.
Okay.
All right, last thing. What do we need to do from there? I think I put here, let's look for. This should be spatial analyst, not geostatistical. Extract points to value. So let's go to tools. I'm just going to do extract points to values. What do we got? For extract values to points. What does this do? It finds the raster value at those red points. So my input features are going to be colleges and universities. My raster is going to be the max. Okay. You know, and I'm trying to keep it really simple here. So now, to be honest with you, watch what I can do. Get rid of that. I'm keeping everything really simple. Now I'm gonna have to go back and we're gonna re-automate this, but I'll do that myself later. Okay, ready? There we go. So when I sort by universities, what I got? Alamance Community College. What do I have as a temperature? 73.59. Now, what am I going to do? I'm just going to So what do I know? What do I have now? I got my data. What am I going to do? Just cut and paste these in order, right? All right, so I guess I'm just gonna, hold on. All right, so the first one, I'm just gonna do 73.59846, enter, right? And then I'm gonna go to 73.9005. Am I gonna do that? Of course not. Yeah. What am I gonna do? I will do a little switch. Copy. Pop those into the cell. And what I'm gonna do, I'm just gonna copy and paste these right into my data. How do I know they're in the right order? Because I already sorted them. Do I want to cover my rear end a little bit? Yeah, sure. Let me look at Elizabeth City, 72.7. Elizabeth City better be 72.7085, and they are. Here we go. So who wants to do this again for all rest of these 6 days? No. Okay. Yep. Paste and then just get that column that you want. Yep, exactly. All right, cool. All right, so now what are we gonna do? What are we gonna now? When we look at our final results, we gotta go do this 5 more times. We're not gonna do this 5 more times. We're gonna do this once for this. Then all you're gonna do is just change the input parameters, maybe even keep the same values, and hopefully everything else changes. So you just at the end, you do what David did. You just cut and paste one column, the next 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 column. And then for each day, you got to find the high, the low, the range, the average. Do you want to go through and hand inspect all those? No. Do we have commands to find the high? It's called the max. How about the low, the min? What's the range? High minus the low. What's the average? Average, right? I think it's called the mean or average or something like that. Okay, so now we're going to go through and automate the processes to do this. All right, now, next. Under analysis, we're going to click on this little thing called Model Builder. Me, I like to dock mine down at the bottom here, but so analysis model builder. Anyone taking geostats? We've already done this, right? Does that ring a bell? Look at the people that nod their heads. See a couple nods back. Okay, model builder. Now, what we're gonna do is we're just going to do what we just did. We're gonna make these as models right here. Do the same thing and be, and then just repeat it. We might run it 6 separate times, but we'll just change instead of 1107, we'll do 1106 and 1105 and 1104 and 1103. And you fix it. All right, so we got tools. First thing we're gonna need to do is what? Export table. Now watch what I can do. Instead of me clicking on this, watch what I can do. Watch what I just did. So I went and looked for export table. I'm going to drag it onto my model. It's got a little arrow. What do you think the little arrow means? You're going in this direction. So I'm going to double click on export table, and what's it look like? I got an input table. Now, do I really need export table? Probably not, but that's all right. We're gonna do it the right way. What's my input table? It already knows. Oh. All right, little bit of that. Why did everything magically change colors? Yep. So I've got a circle. These rectangles mean this is a process. Input parameters. We do an export table. It exports into this. What do we do next? What do we do next? We did add XY data.
Yeah.
How do you find out XY data? I bet you in geoprocessing, if I did add X, Y coordinates. Uh-oh. No, it's not add XY. What is it? XY table to point. There we go. What's the next thing we do? XY table to point? What's the input parameter? What's the input parameter? The thing that we got as a result of the other one. So this thing's going to go into this. So we create a new feature class that does this.
So did you just drag the XY table to point?
Yep. So what's the input table? This? Yep. Whatever the last thing you created.
So it's still the same, which is the same though, as what we did for the first.
Mm-hmm.
Guys, we used the same.
Yeah. How do I get what? I'm not on IWM yet.
Okay, I don't know. I was close, but.
Don't so much. Don't know how, God. Jesus. Slap off. Yes, okay. Okay, Will had a good observation where that you need the X's and Y's. The whole point is we need a column for the X's and Y's. Okay? What's next? So now what do we do? Exported the table to the database. We did add XY. Alright, so we did it. Now we created this whole thing. If I really want to, I could run this thing, and what do you think will result? A whole big map of stuff. All right, what's next? Let's just select by location. Well, it's called select layer by location. Hope it is.
I missed that seconds.
Seeing if there's another one real quick. Okay. I'm seeing if there's a different tool to do this. All right, let's try this. All right. So did the select button. Export features.
Yes. And yes. We pay.
Okay. So first thing I've done. Export the table, didn't really need to do that. I did XY table to point, so I've got the new feature class of the entire United States. And then I did a select by location to this, where then I just exported the features to just get the 50 of within 50 miles of this, right? It's all right if we don't get it, no big deal. We're kind of getting it.
Halfway follow.
That's okay. All right, what do we do it after that? And if I really wanted to, watch what I could do, and I'm just gonna do it here myself. I'm just gonna go through and run it. I can go through it and run it here. Here. You. Go. So this really is working here. It really is. Okay. All right. But properties, we can click on these properties. Parameters. This is what we're gonna be working with later. Let's validate. Okay. What's the last two things we need to do? Run an IDW on it. Using the, yeah, it's just drag and drop. What's the input parameter for this? Whatever the result was here. Using the amount. Then what's the last thing? Yeah. And what's that thing called? Something like that. Extract values to pointer. And what's going to be the input parameter on this? It's going to be the colleges and universities with the IDW. You guys are better at this. Now, how many of these did we do? We did like 5, right? So we can create iterators and all those other things. There's a way that we can set it up here so that one of the things we could do is we can export this graphic. So people can look at this. And then the other thing we can do is we can send it to a Python. So we've converted all of this. You all wrote. Yeah. So this is the Python code that, now what do you see here? Table, create, export features equals this. Now, if I wanted to run this again for another date, what could you probably do? Just change this original, run it again. Hopefully it'll give you the same thing. I'm gonna say hopefully, because class is coming to an end and I don't want to keep you here too long. But I'm gonna play with this tonight a little bit tomorrow morning because I want to be able to run this. So I want to be able to run this and you be able to see the results here. And you be able to see the results. Daniel or Andy, where's Andy? Is there a way for this model builder that we can see the results show up in table of contents while we're running it? What's that? Oh, add to display. Oh, here it is. Right mouse click, add to display. Oh, it's this one, add to display. Already did. Okay. There we go. There it is. So we can add these to the display. Why can't I add this to the display? Exactly, it's a process. Exactly. So now we can go through the process and see as we do these. Pretty slick, real slick. Now, I'm just about done here and I don't want to talk anymore. I don't think you all want to hear me talk. Now, do we really need to convert it to a table? No, we could probably just bring in the raw TXT file and we all can be better for it because at the end of the day, what do we want filled out? This big old thing. And then we can use the Excel to find the high, the low, the range, and the other thing, a range and the average, then down at the bottom. So now you can tell me, hey, which university has the highest range over a week? What's the average temperature over that week-long period? Because eventually what you can do is load in the dates and the names of each of the files, and you're just going to stick these into a big old loop and run it every single time. Say, hey, do 11/07/2023. Next time, do 11/08/2023. Do 11/09/2023. Keep iterating these through. But for now, we're just going to spend the week filling in the rest of this table. How's that sound? Doable? All right, cool. I see a lot of head nods there. That's good. Because I'm a little unsure myself here. I just want to go back and be able to run it and like, oh, you got the wrong thing. And so, yeah, call it like temp 1, temp 2, temp 3. So you can just overwrite them every time because you don't really care about the values while you run it. All you want to do is extract from the IDW. Who cares about that IDW once you run it? And so if you just keep overwriting it, it's not going to matter because at the end of the day, what do we want? The answer. Okay, so I'll leave everyone at that there. I'll post a recording on that and I'll probably post this mid-morning tomorrow after some meetings. And I kind of go through a little bit more insights on some of the tips and tricks related to this. So I'll leave everyone here. Everyone have a good night. Everyone joining us online, have a great night. Welcome to Data Science. This is kind of what it's going to look like. And I look forward to what you have to turn into next week. I know the learning curve steep for a couple people here, but it's all stuff we did in previous classes. Throw in a little IDW and we'll be fine. So All right, I'll see you all later.
See you, Doug. We're ready.
All right, see you.
Andy, you ready for my email?
Thank you. Bye.
All right, see you. See you, one.
Have a good night.
All right, you too.
Bye.
Thank you,
All right.
Dr. Lauren. See you on Wednesday.
All right, see you.